Okay, Nathaniel, this is the arched window question. I'm a bit confused as to whether this is a technology allowed question, because certainly with my students, this question and question 9, I'd be having them solve it using technology. The numbers are pretty awful to do it by hand. I'll show you how to do it by hand. I'm not going to do number 9 by hand. Those numbers are ridiculously large, and it would make sense to have it as a technology allowed question. But in question 8, we've got this arch. The arch is 1.5 across and 3.1 up, and we know that's 2.5. So really, this bit here is a height of 0.6, and that's 1.5, which gives me this interpretation. I know because of the parabola that it's symmetrical, so this is going to be 0.75, a half of the 1.5, and that height will be 0.6. And when working by hand, it's much easier to deal in fractions. So that's 0, that's 3 on 2, that's 3/4, and that's 2/5. 3/5. Okay, so that gives us 3 coordinates, 0, 0, 3/4 and 3/5, 3 halves and 0. I'll plug each of them into the general form and come up with 3 equations and 3 unknowns and solve them. So putting in 0, 0 equals c. Straight away I know that c equals 0, because when x equals 0, this term and this term don't exist. So really, I know that y equals ax squared plus bx, because I know that c is 0. Something in my second point, I have 3/5 equals a times 3/4 squared plus b times 3/4. 3/5 equals 9 on 16a plus 3 on 4b. And that's what I'm going to call equation number 1. Subbing in the other piece of information, 0 will equal a times 3 on 2 squared plus b times 3 on 2. 0 equals 9a on 4 plus 3b on 2. Now, I have 2 equations and 2 unknowns, a and b, but I've got all these fractions. Since this is quite straightforward, what I might use is a substitution method to try and find a and b. That is, I'll move this to make it minus 3b on 2 equals 9a on 4. I've got minus 3 on 2 times, the 4 will come up and multiply, the 9 will go across and divide, and that's what a equals. A equals 3 goes into 9 3 times, 2 goes into 4 twice. A equals minus 2b on 3. There's also a b there that I didn't write. So what I'd like to do is substitute into equation 1 that value, which is minus 2b on 3, in preference to a. So equation 1 becomes 3/5 equals 9 on 16 times minus 2b on 3 plus 3 on 4b. 3 goes into 9 3 times, 2 goes into that 8 times. 3/5 equals minus 3b on 8 plus 3/4 b, which is the same as 6b on 8. 3/5 equals minus 3 plus 6 is 3b on 8. So 3/5 times 8/3 equals b. b equals 8/5. And since b equals 8/5, a will equal minus 2/3 times 8/5, which is 16 on 15. Which gives me an answer of y equals a, which is 16 on 15x squared plus 8 on 5x. What would that look like using the turning point form to see if that is an alternative method that is easier, different, faster, preferred? Okay, I know the turning point is at 3/4, 3/5. So I'm going to have y equals a, x minus 3/4 squared plus 3/5. Substituting in 0, 0, 0 equals a minus 3 on 4 squared plus 3 on 5. 0 equals 9, a on 16 plus 3 on 5, minus 3 on 5 equals 9a on 16, minus 3 times 16 on 5 times 9 equals a, 3 goes into that 3 times, I end up with minus 16 on 15 equals a. Now I've got a negative 16 on 15, but over the page I should have got a negative 16 on 15 as well, so that's correct, same answer. I need to find out what, I know what the equation is. The equation should then be y equals minus 16 on 15, x minus 3 on 4 squared plus 3/5. That's in turning point form. If you expand and simplify, you'll get in the form that was requested. So it's going to be minus 16 on 15 times x minus 3/4 squared. I'll write that out. It's going to be minus 16 on 15, x squared minus 3 on 2x plus 9 on 16 plus 3 on 5. It's going to equal minus 16 on 15 x squared minus 16 on 15 times 3 on 2x plus minus 16 on 15 times 9 on 16 plus 3 on 5. Minus 16 on 15 x squared minus 2 goes into that 8, 3 goes into that 5, 8 on 5x minus 16, 16, 3, 5, 3/5 plus 3/5. They cancel themselves. Same answer as over the page.